Hello students, in this video we'll prove the direct comparison results for convergence of infinite series. Let's suppose that we have a sequence of real numbers, sequence an, n goes from 1 to infinity, and a sequence bn, n goes from 1 to infinity, with the condition with the inequalities that, of course, 0 bigger than or equal to the absolute value of an, because the n absolute value is bigger than or equal to 0, and that's going to be less than or equal to these terms over here, bn, and the sum n goes from 0 to infinity, or in this case 1 to infinity. We can put these, we can index these at 0 or 1, doesn't matter where they start. Bn convergent implies that the sum n goes from 0 to infinity of an convergent. Okay, so we're going to try to use our Cauchy criterion here. So let's let epsilon be greater than 0 and choose n and epsilon in n such that what? Such that b m plus 1 plus bn less than epsilon if n bigger than m bigger than or equal to n epsilon. And of course here the absolute values are redundant because the bn by assumption are non-negative, but this is exactly just the Cauchy criterion for the sequence bn converging. Okay, again, I don't want to do the absolute value, but now let's use the same n and n, so let's consider a m plus 1 plus all the way down to a n. By the triangle inequality, this is less than or equal to absolute value of a m plus 1 plus absolute value of a n. Now each of the a n's and absolute value are less than the b's, so this is less than the entire sum, bm plus 1 all the way down to bn, just by direct comparison, less than or equal to, and this is less than epsilon. So what we've shown is we've shown that our series over here satisfies the Cauchy criterion. So the series j goes from 0 to infinity of aj satisfies the Cauchy criterion for convergence, and therefore it converges. Immediate consequence of this result is the corresponding thing for divergent series, right? So also we have this, so remark, the remark is the following: if we have a situation like this, if we have an bigger than or equal to bn bigger than or equal to 0, and the sum n goes from 0 to infinity of the bn is diverging, this is divergent, then as the counterpositive of this, this automatically implies what? This automatically implies the sum n goes from 0 to infinity of the an diverges. So this is very useful because we can make cheap inequality estimates, cheap estimates on terms in a sequence. We can use either one of these results. So in other words, the upshot is that if you have a bigger sequence that's converging and the absolute value of your terms are less than that bigger sequence, then your series will converge. And likewise, if you're smaller than a divergent series, you're also going to diverge. So the intuitively obvious things about comparison are true for series. Thank you very much.